Good morning, good afternoon, this is Lucy Donegan. I am going to show a way to capture and prepare and analyze road center lines for angular segment analysis. For this I need to have Anaconda, OSM with Spider attached to OSM QGIS with the plugin Space Index Toolkit and depth map installed in my computer. I have all of these open here already for this exercise, and I could look at other things I can do with OSM by reading its documentation, and I can check how to install it here after already having Anaconda, and I can also check internals reference other capabilities. For this exercise we're going to use the OSM graph module, and you can read a bit more about the capabilities by reading the documentation. So first I can check in my Anaconda. If you have Windows as I do, I'd have to have installed the OSM environment, and after installing it, it's going to appear here, and I have it checked here. I've launched Spider through here in this environment. I've already opened it here, and I have a few things written down for this exercise to download OSM via OSM. So first I have to import OSM. I can do this by running this selection here in Spider. And after this has finished, it's going to show another entry for me. I'm going to do the small exercise with Lucena, which is just north of João Pessoa in Paraíba. I can call it L, and I can ask for a graph from place from Lucena. And I can check in by my variable explorer the size of this graph. When I checked it just like this, all the routes are going to be downloaded, but I could also ask for an LD, and I could say that my network type that I want is drive. I can have a look at these two different ones that are different in size by asking to plot the graph. I could just plot the L one and have a look. And all this comes. And I could also plot it with the other one that I downloaded. It's just a drive one. So I have a lot less routes here in the middle, and I can see that this area seems more dense. And this is a bit sparser. Maybe it's not an urban area. Another thing that I could do is use a graph from address 1, because when I get the one from place, I'm getting the whole of Lucena municipality. And I've done these three other types of selections. And I'm first asking a graph from address saying Lucena, drive, and putting a distance of 2,000 meters. This will give me something smaller than the other ones. I can have a look at it here. 2 kilometers. That's how I called it. So I have something like this. If I haven't set the distance type, it's going to get a box. But I could also try from what they call Lucena, the center of Lucena as an address. I could get 4,000 meters from it in a network type of distance. So if I plot this, I get a different type of network from the 2-kilometer box. And I could also not put that the network type is drive if I also wanted to get other routes as cyclable or walkable routes. And then I would take this D out just so I know it's a different network. And I could have a look at it. And I get a few more routes, especially the ones that are close to the coast, that are only walkable, I imagine. If I am happy with what I have here, I can choose the model that I want, and I could ask for it to be saved in my computer. I also need to check which folder I have here because it's going to take the file to this folder. So I'm first going to just get the Lucena one. So I'm going to open now my QGIS because I'm going to simplify it here, and then I am going to analyze it for angular segment analysis. I go for layer, add vector layer, and I'm going to look for that file here in SSS14. It's this one, and I'm going to select the edges shapefile. I can look at it over Google Satellite as well, but this edges coming from OSM and X, they are in a geographic coordinate reference system. So I have to export it into a planar system so I can read meters when I'm simplifying it. I'm going to look for a destination for the file, and I'm going to call it this. I've already done it before, but I'll overwrite it. And I'm going to call it Lucena 4 kilometers drive planar. So I have to check here to get a new CRS. And I'm going to look for a SAD 69, which is the location for the coordinate reference system for Jean Pessoa. You have to check the one that's appropriate for your situation. I'm going to select this, and it's going to add the saved file to map. I'm going to overwrite it because I already did this exercise before. Now I can simplify. We can do this by using QGIS geometry tools, vector geometry tools, simplify, with Douglas Perker, and we'll use a 5 tolerance, which was a tolerance that we found appropriate in other exercises that we did. I'm going to leave it as a temporary layer for now because I first want to check it. So this is a simplified one, and I can have a look to see if everything looks okay, and it does. It's a bit different from the original one, but not missing valuable information. It's a bit different from the... I'm going to save this one, which is a temporary file, as the simplified one, and I'm going to call it simp5. I'm going to overwrite it, and now I can erase this one, remove this one. And I don't want to see these ones now. So after I've done this, I'll open my Space Syntax Toolkit graph analysis. I have to check that I have this depth map installed and opened. and I'm going to check this file. I have to say that it's a road center line. I can look at the settings. I want Nash and Ain and choice and a metric radius type. And for this, I'm just going to do an N and a 500 meter one and calculate. I'm going to override it. So here I have the analysis. I can have a look here at the attribute table to see what I have now. So now I have choice 500, integration, Nash, Naim. I could explore the visuals of these metrics by going to Attribute Explorer, or I could also use QGIS, Properties, Symbology, and because I have numbers, I'm going to look for graduated symbology, and I'm going to look at integration for now. I'll put this spectral, but also invert the color ramp and classify, and these are the intervals that I'm going to look at. I could leave it at equal count. I'm going to have a look at it like this. I could look at equal counts because then I have an equal amount of features in each interval. And I could also change the width. I'm just going to put it at 0.4. So I could look at it like this, or I could also use Jenks. Either way, how you're going to present it, you have to clarify in your methods. So with Jenks, I end up emphasizing the highest ones. I could also have a look at the feature count for this, and if I had the natural equal counts, then I'd be looking at the same amount for each group. I'd also test other models like the walkable ones, walkable routes. Thank you for your attention.